Someone is not telling me that I'm not sharing my screen.
And there's an echo. You could push the other device mbali kidogo.
Okay, thank you, Boniface. Yeah, I think my screen is now visible. Someone confirm. Good. I think we should have a class monitor. Now that I was teaching myself here, and I think we should have a class representative, not a monitor. So, by the way, I was saying that to sprint a 2D array, we use this array underscore sprint method, and I'm hoping that I'm recording these. Good. I think that's okay. So, yeah, we use array underscore split method, and then you pass the number of times that you want to sprint that to the array. So for you're going to have two parameters in that method. That is the array itself, the 2D array itself, and the number of times that you want to print that array. So, and I think this example is quite clear on how to do that. I think you can just run this example so that we can see. You can see this print in action. So let's run this. So the first step is always to import numpy as np, and then we create an array. In this case it's called array. I think I should add something like 2D, or maybe something 2D. No array. Let's just call it an array. Let's go 2D. I think that makes sense. And then is equals to np dot array. You remember how you were creating the array by using the array method again. So inside the parentheses, we just pass in the list of no, the array that you want to create here. So in this case, I have to the array. Yes, I have to the array, and I want to sprint this into three times. So for me to do that, I'll just have a new variable, which is the new array, or maybe let's have array after split. Array after split is equals to the np, and then we invoke we call our array underscore split method, and then here we're just going to pass in our array underscore 2d, and then we pass the number of times that we want to divide that array. I think that is quite clear. So I'll just have to print that. I think you can even type it. So let's have array underscore split. No, is it after? No, it's underscore after underscore split. Good. I think we can just run this. Let's see the output. Yes, do you notice that our array is divided into three times? This is our first time up to that point. This is our second point up to this point, and then this is our third point up to that point. So simply that is how uh, basically that is how we do the sprinting of 2D array, and that applies to even the other types of array. Can have a 3-dimensional, 4-dimensional. Yeah, I think that is it with sprinting using the array underscore sprint method. And I don't want to spend much time on that. I think we have done a number of examples now with this print. So I think we can check something different. Yeah, I think that's all about that. What am I leaving behind? Yeah, there is another there is other two concepts that I want us to cover. That is the sort and filter. So and I think we can just start with sort. And what is sorting? I think we have the definition here that sorting means putting elements in an ordered sequence. So we can sort our arrays again. So we say that ordered sequence is any sequence that has an order corresponding to elements like numerics, you can have or alphabetical. So sorting can be ascending or descending, right? And I need us just to check how we do sorting in Numpy. And we see that Numpy ND array object has a function called sort that will sort a specified array. So again, this is just quite simple on how we do sorting in Numpy, because again we are provided with a function to do that. You notice that Python is all about functions, right? This is the simplest language that you can ever learn, because much work is done for you. So again, to do a sort, let's just have an example of maybe you could have a list of items that you want to sort, and you can just have an example on that. And that example, I think you can just copy these and run it. Good. You can just indicate that you are doing sorting in Numpy. Sort in the wrong cell. Sorting in Numpy. I think we have already an example here whereby we import Numpy as NP, and then we just create an array. In this case, we have an array with 4 elements, and we want to sort these arrays. So what do? We just have to from NP, which is our NPy, we just have to invoke that method that is called sort, and then we just pass in our array. If we were to run this, you notice that we are going to have a sorted array, and by default sorting is will always like arrange things in ascending order. That is by default. As you can see, you can just try and just play around with these numbers. You can have 10, and maybe you can have something like 71. If you just try to run this again, you notice that you are going to sort this array in an ascending order. So that's all about sorting, and it's quite similar to even the other concept of filtering. Maybe you can just go through the filtering, then we go to something different. We go to our next library that I want us to learn. Let us just check this last concept here in Numpy. Mm, Why is this filtering arrays? So getting some element out of an existing array and creating a new array out of them is called filtering. So that is the definition of that filter. So we say that in NumPy, you filter an array using a Boolean index. I think you're just going to see that. And what is a Boolean index list? So you're saying that a Boolean index list is a list of booleans corresponding to indices in the array. Um, so this is quite easy. How we define an array, and then we define another list of the true and false, that is the boolean. And then, because these two, okay, before we get even to an example, let's say that we have something that if the value at index is true, then that element is contained in the filtered array. And if that value at that index is false, then the element is excluded from the filtered array. So this simply means that if you had an array of four elements, to filter this, you must define another list of true and false, depending on the value that you want to remain in your array. So if you want the element to remain, you just set it to true, and if you want to remove the element, you just set it to false, like in this case. And then you're just going uh, to assign that the new array is the value of x. So it's just quite simple how we do that. Like in this example, we are saying that in the above example, we'll return, that is 41 and 20. No, that is 41 and 43. Why? Simply because that at first index here, we have 41, and the list that is helping us to filter the array. You notice that the first index here, again, it is named as true. So meaning that whenever you have a true, that value will remain, right? And whenever you have a false, that element will be omitted. So you notice that in this case we have a true in the first index, which is 41. The second one is false, and the third one is a true, and the last one is false. So meaning that we're supposed to remain with 41 and 43, and that is the explanation. This is the explanation behind that. So, but you are saying that creating the filtered array, you are saying um, you see that in the example above, we had coded the true and false values. But the common use is to create a filtered array based on condition. Yeah, let's assume that you had a larger list, maybe a list with 20 elements or maybe 30 elements. What do you do? You have to create a list with 30 Boolean values, just to indicate whether you want to include or exclude that value. So we are saying the remedy to that, we just have to create the array based on conditions. And I think we learned how to create a condition. So let us just see an example here of that condition. I think I have a very good example here, and we can go through it together, so that we can see the output. Let me just copy this to save time. Then we go line by line. Here we are trying to filter using condition. And this is the example that we have. We can just uncomment this. This one is to remain as a comment. So what is the first step? The first step is always to import the Numpy, and the second step here is to create your array. Filtering using a condition, then it means that you must have you must create an empty list, and in this case we're just creating a list that is called filtered underscore array. I think that one will I think this one will mess up, but let me show you something. I think we can just control D. So if let's say you want to edit multiple maybe multiple similar values, you can just I think you can just highlight the this is a shortcut for those of us who might be interested. So let's say you want to filter all the values that with filter underscore array. So you just have to highlight these, and then you control D. You notice that all the filtered underscore array will be highlighted. And then maybe you can just press the cursor where you want to edit. Like in this case, I just want it to be filtered array. And you notice by I can change multiple values here, or multiple words. So that is it. So I just wanted to be a filtered underscore array, and you notice this is my empty list. So this list is where we are going to place all the values that we need after going through a condition. So the next thing that you're going to do is go through each element in array. I think by now you know that going through each an element in array, we use a for loop. So we are saying for element in array, and the array, this is I think we should call this array, or maybe R. It can just remain it's just a variable name. So just decided to call it that way, R. So we are saying that for each and every element in our R here, or array, all these, what do we want to do with that after looping through? So we want, if the element is higher than 42, set the value to true. Otherwise, it will be false. Just as we said here up that the only way you are going to filter your array is through setting some values to true or false, right? So that is what we want to do with our code. And in this case, we are just going. It's a condition we are passing to. We are passing in here. So we are saying if the element is higher than 42, we set its value to true. Otherwise, false. So how do we do that? We say that if now element is greater than 42, sorry, excuse me. So we want to after, if the element is greater than 42, we just want to append that value true to our list here, and that is why we are using filtered underscore r dot append true. then else filtered underscore r dot append false. So what we are doing here is we are going to do a check. If the element is greater than 42, it's going to be set as true. And if it is set as true, it's going to be appended in our filtered array. Else, it will not be, it will just remain to append false, append and pass in a false, meaning that we are not going to, in fact, this means that we are not going to append because the value, the boolean value here is true, is false, I mean. So we're just going to have all the values with values greater than 42 in our list. So that is the condition that we have passed. I think it's just quite easy. This is the condition. We loop and then we just pass the condition. So after that, we want now our new array to be equal to the array and then the filtered array. You notice that the filtered array now will carry all the values that are greater than 42. And that is what we are passing. We are passing in our new array here. So let us just try to, I think the first thing we can do, we can just try to print the filtered array and see the output. And then you are going to print the new array. So let's run this. So you notice that the filtered array now is having all the values of they have the boolean values. If the value is greater than 42, we have a true, and if it is less than if it is otherwise, we have a false. You notice that these the filtered array here is just like the one that we were just creating using hard-coded values. So this one will help us again now to create our new array. So if I were to print out now the new array here, I'm just going to have 43 and 42, and these are the values that are greater than 42. What if we change this one to maybe less than 42, and it just happened to run this? It's just going to have one value here, which is 41, and 41 is less than 42. So are we good up to that point? Any question? There is a question from, that is Deacon. What is the question, Deacon?
Yes, can we maybe put less or equal to greater than or equal to?
Yes, you can.
But it's okay.
Yeah, you can do that. Any other question? Thumbs up if we are good. Good. I think we are okay with that. So that is two ways of doing filtering in Python, and that marks our end of our NumPy lecture. So if there is no question about NumPy library, I think we can just move forward to the next library that will help us do some visualization. I think you did visualization in Excel and also in Python. In Python, we have visuals. You can visualize. You can create some pie charts. You can create some bar graphs. You can create some histograms, right? Using the library that you're going to learn next. And, it's an interesting library again in Python. And it's called MatPlotLib. Well, have ever heard of that library? MatPlotLib. Any person? Kuna mtu ashaisikia hiyo? I think it's just right here. Yes, MatPlotLib. And I think we're just going to start by definition. And we are saying that MatPlotLib is a low-level graph plotting library in Python that serves as a visualization utility. So basically, it will just going to help us to plot some visuals using now codes. And we are saying that MatPlotLib is an open source, and you can use it freely. So meaning that what it means by saying that MatPlotLib is an open source, it means that you don't pay for it. Notice maybe there is some libraries that you have maybe to pay for them, but this one is it's an open source, so you can import it in your work and use it freely. So as we always do with libraries, let's learn how to do the installation of the MatPlotLib. And again, it's quite easy when it comes to Python because I introduced something that is called pip. That is a package installation tool. And also in this case, we are just going to, for those of us who are using different IDEs, we are going to use again pip to do some installation. That is pip install MatPlotLib. And that is it. You should have it. And even there is a way you can check its version. I think it's indicated in the notes. Like I shared these notes with you guys. You can see how to check its version. So after maybe doing the installation, there is something I want us also to check. There is something we call MatPlotLib pipeplot. And pipeplot, it's a submodule. I can call it a submodule of MatPlotLib. And the submodule will help us to just do some will help us with like most methods, right? Because you understand that in Python everything is like just a method. You just have to invoke it. So you notice that most of the MatPlotLib methods they are in they are in this submodule that is called pipeplot. And anytime that now we are using the MatPlotLib, we are just going to be using matplotlib.pipeplot so that we can have all the methods that are going to be used in doing visualization. So we are saying that most of the MatPlotLib utilities lies under the pipeplot submodule and are usually imported under the PLT alias. I think alias. I think we saw this again with Numpy. We saw that with pandas. So this one we are going to use the PLT So import matplotlib.pyplot as plt, and that is it. So we can, I think you can just start to draw some visuals, just simple visuals. Maybe drawing a line, or see how you can plot a line using the library. Yeah, what you need to in order to draw a line in using the library. So we're just going to start with a very simple example here, and the example asks us to draw a line in a diagram from position 00 to position 6, 250. So how do we do that? If you are told to do that, maybe a assignment, a cut. So the first thing is to import matplotlib.pyplot as plt, and then now you notice that we are going to need Numpy. So now we have started importing two libraries when doing our math, our plot here. So things, as we learn, things get complex. So you notice that now we are going to need two Numpy, two libraries here. That is the Numpy and the MatPlotLib. So who can tell us the importance of having this Numpy as NP while doing this plot? Now that we have just learned what Numpy is used for, who would tell us what is the need for having Numpy in this case? Can we have a random person to answer that before I select someone? Why should we need this Numpy while doing the plot? Any person who can guess that? Any person? Why do we need Numpy in this case? What did we say the use of what did we say is the use of Numpy in Python? Any person who is willing to answer that?
We say that numpys are used to create arrays.
Yes, good. So Dickens, why do you use Numpy in this case?
I don't have an idea.
But you already told us the answer, so it's kind of an application here now. You notice that to for you to have x point and y point. In here we are dealing with numbers, right? And in this case we are dealing with arrays, not lists, right? So we must convert this list into an array, so that we are able to maybe to have a point x where we have a point x is 0, 6. The point y where we have 0 to 50. But we cannot work with the list here. That is basically the reason why we are using Numpy, because we simply need to work with. You notice that these x and y points, they are in array format, but you cannot work with them when they are in list format. So that is simply the reason why we are converting these points into an array so that we're able to work with them. So you notice that in this case, while doing the x point and y point, x point has its values as 0, 6, and the y point has its point as 0 to 50. But you notice that we are told draw a line diagram from position 0, 0 to position 6, 6 to 6,250. Why do we have x point as 0, 6 and not 0, 0? Can someone answer that from the basic math that you guys learned? Because again, if you don't understand this, I don't think you are going to solve such problems. So at x point, I have values 0, 6, and y point I have 0 to 50. But from the question we have draw a line in a diagram from the position 0, 0 to position 6 to 50. So can maybe someone try to explain that? We can have a lady this time. Yes, I think we have. Lewis, I think we can. Yeah, Lewis, help us.
But I'm not a lady. So my thinking is the array 06 will form the vertical axis. Sorry, the horizontal axis.
Yeah.
And then 0 to 50 will form the vertical axis.
Good. Any other person with a different answer? But by the way, how do we define coordinates? So you always have x and x comma y, right? Because if you don't understand this, then I think we have always like coordinates. They are written in form of x and y. And you notice that in this at this position 0, 0, we have x and we have y. And also the other to the next position you have x, y, right? So as Lewis has just said that now 0, 6 will form the horizontal axis. So it will be 0, 0, 6. Because you are checking the point at the horizontal, that point 0, 6 at the horizontal axis. We have 0 to 50 at the y-axis. So that is basically that, or the reason behind why we are using 0, 6 and not 0, 0. And we are using also 0 to 50 and not 650. because you notice that the coordinates of a line, they are written in form of x and y. So any point that you are given, it has an x and a y value. So I think that is basically that. I think it makes sense. So we just have like to have the x point as 0, 6, and we have our y point as 0 to 50, and then after having our x and y points, then we just have to invoke the plot method from the PLT, or what we are calling the MatPlotLib.pyplot. And what do we pass in? We just pass in our x coordinates and our y coordinates, and then we tell that we just guide these to, we just have another method that will tell our program to show that line. So again, it is plt.show. So if we run this, we are supposed to come up with a graph now that has 0, 0 point to 6 to 50. Any question? I think this is just something simple. Any question on how we just drew the line? Any question? Mario? Mario is okay. So, Dickens?
Yeah, I've seen something like PLT. What does it necessarily mean?
Good. I think I said that. It's just the PLT is just you can use this MatPlotLib.pyplot, but it's a shorthand, or maybe instead of having like writing all these, you just use the short form, the shorthand for these, and that is why we said we use the PLT as what, as an alias. How do you pronounce this word? I think it's just here. Is this matplot thing? Using PLT as a alias name for matplotlib.pyplot. I think it's just here. You just mentioned as we were introducing this. I think it's just right here. So we are seeing that most of the matplotlib utilities lies under the pyplot submodule and are usually imported under the PLT alias. This one is always like is a shorthand for what we have here, the matplotlib.pyplot. So instead of writing these all through your code, you just shorten that to something like PLT. Are we good, Dickens? Dickens, are we good?
Yes, I'm okay.
Good. Any other question? I think it's not magic. Yeah, we just have a line there of just a simple line, but there is so much to learn. because you understand a graph must maybe meet some graph must have some titles, some naming, right? That is the naming of the x and y axis, giving it a title. There is so much this graph is lacking, but we are going to see that. So that is basically, you can just try to draw a line on your IDEs. In case you have an issue, you can just ask us to help you. I think that is just the simplest plot you can ever have. That is a line graph. Yeah, and since there is no any question in that, I think I can just move to MatPlotLib plotting. And we are saying that plotting x and y points. I think you have already seen that. So the plot function is used to draw points. Just assume we don't have that markers, but you're going to see you can just assume at the initial stages that you didn't see these markers, right, in the diagram. So we are saying that by default, the plot function draws a line from point to point. And we are saying that the function takes parameters for specifying points in the diagram. I think we have seen that, where we are passing the x point and y points. So we say that parameter 1 is an array containing the points on the x-axis, and parameter 2 is an array containing points on the y-axis. So if we need to plot lines from 1, 3 to 8, 10, we have to pass two arrays, and that is 1, 8 and 3, 10 to plot a function. I think that all these make sense from what we have just done. So I think we can just have this example done using the code, whereby we are told that draw a line diagram from position 1, 1, 3 to position 8, 10. So I think the best way is just to choose a random person and help us to do this. Well, I think we should do this one together, and then the next you'll have someone to do for us. So just be ready. You can be chosen. I think we're just going to have a lady and a gentleman to do that. So let's do this together, and then the next two we are going to have people to do that. So let us just copy these, and then I take you through that. Let me just copy these. Good. So the first step here is always to import matplotlib.pyplot as plt. And then we import numpy as np. And then we just have to define our x point and y points. So in this case, we have 1 and 8 as our x point, and we have 3, 10 as our y points. So after that, we just have to invoke the plot method that is from plt. So plt.plot, and then we just pass in our x points and our y points. And then we are just going to show that graph. So if I were to run these, you notice again I'm getting a very good, very straight line here. That is from 2 to point. That is 0.18 and 0.310. So can we have a lady, a volunteer before I choose one, and we can have a gentleman to do this question. Yes, I think we can have. Let me just have this question here. I think you can have the first one here. Draw a line in a diagram from position. Maybe let's say start from position 3. Three, maybe something 320, and we need to have a 2, and yeah, I think that one can remain. That who is doing this? This one is for ladies. So a volunteer. Let me have a volunteer. We are drawing a line in a diagram from position 320 to position 2 to 50. Who is helping us to draw this line? Ladies. Yeah, I thought this one was very simple. Can you have someone? Rose. Rose, where do we start? I think Rose, you can help us.
Okay. Yeah.
Do you prefer to show your screen or like just write what you say?
Write what I say.
Okay, good.
Import MatPlotLib.
Wait. I don't like these. I don't like these AI thing. So import
MatPlotLib.pyplot.
I don't like this. I think I should disable that. I don't want this. So let's have that. Import matplotlib.pyplot as DLT. Is that the thing you said?
Yes. Then import Numpy as NP.
Import numpy as NP.
And then X points
You can have X point.
is equals to
Yeah.
NP.array.
Just a minute. Okay, let's start by the indentation here. That is good. So we have NP dot array.
Dot array.
Yes.
Yeah. Brackets. Square brackets 3 2.
We have 3 comma 2. Yes.
And then Y points. Y points
Okay, let's have y point.
is equals to
NP
dot array. NP dot array
yes.
brackets 2, square brackets 20 to 50.
20 to 50.
Yes.
Yes.
And then plt dot plot.
plt dot plot
Bracket x points, comma y points.
Yes, I think that is it. And then
Yes. Yeah.
we can just run these. And we're supposed to have our line here. Exactly that. I think we are good. It's only that I haven't learned how to disable these. I think by today I should be able to hack how to disable that AI thing. So, but anyway, that is that. Okay, for Jen, okay, who is volunteering to do the next?
James, your graph is funny. I think instead of in the X point, instead of inputting 320, you captured 32.
On 3-2.
Should be 320.
No. It should be 3-2.
But look, read that statement. Draw a line in a diagram position. 320 to position 2 to 50. But under your X point.
Yes.
NP array and then bracket. And that is 3 2.
Okay, what is our horizontal points here? What is our X points? It should be 3 and 20 or 3 and 2. I think there is something that I explained that the coordinates they are written in form of X and Y, right? So 3 in this case is the X, and Y here is the 20 is the Y. Also in the next point we have X axis and Y axis. So for us to have the X point, you just have to bring the two X points. That is the 3 and 2. Are we good?
Yeah.
Yeah, that should be the case.
Then 20 and 50.
Then
250.
20 and 250.
Okay.
That is what we have here. So I think that is it. It's just quite simple. I thought I did clarify that. That is from the basic maths. When we were drawing some graphs. Draw a graph from a certain point that is blah blah to a certain point, blah blah blah, and then you have to know the x-axis and the y-axis. So I think that is it. Can you have a gentleman to do for us this? I think now I can just have draw a line diagram to maybe from something like from maybe 10 axis, okay, 100 and maybe 5 150. Can you have that done? Who is willing to do that? And this one I want us to do it in a different cell again. Who is willing to help us with this? Have Dickens. Dickens, you can help us with this.
Yes, just to start, you can type import matplot.
What I can do, just a minute.
Yes.
I think I can just so that you cannot have AI helping you, but it's still helping you. I don't know. What did you tell AI? Why did you tell AI to help you? But let's see. Let's see that import. You said
Yes, I said the import matplot lib
plot.
dot pyplot
Yes.
as plt,
As PLT.
and then import numpy.
Then we have to import number
np.
as NP, right?
Yes,
Okay. The next thing.
and then we have x points
Yes. X point.
is equal to np
Yes.
dot array, and then you open the bracket.
So we have X points. We even have previous point.
And then you insert square brackets within,
Yes.
and then the first value is 10, 5.
10, 5.
Yeah,
The second thing.
and you go to the next one, which is y points is equal to np dot array.
Yeah.
You open the brackets and then square brackets, and within the square bracket we have 100, 150.
Yes. After
And
that.
then after that we have plt dot plot.
Yes.
And then you open the brackets,
Yes.
x points comma y points,
Yes.
and then the next line we have the next cell, I mean, we have plt
Yes.
dot show, then you open the bracket.
Something like this.
Yeah, sure.
I think you can run this again. Yes, and you notice again you have a line with a negative gradient. Is this one a negative gradient? I think it should be a negative gradient. Yeah, that is it. That is all about maybe plotting some lines. You can just do some more examples. You can just do some more examples for practice. So what next after that? Let's just learn something important here. We are seeing that the x-axis again is the horizontal axis, and we have a y-axis is the vertical axis. I think we have already said that. So the next thing I want us to learn is something we call something I said you guys to assume, that is markers. So MatPlotLib markers. So maybe you can have a straight line, but in this case you use marker. You use a marker. You can just decide to use some X. You can decide to use maybe some dots. To create a line. So how do you go about that? So we are saying that you can use the keyword argument marker to emphasize each point with a marker, and that is just quite easy, because again we have an example here. So you're also going to draw a line. You can have a dotted line, you can have,
James,
yes,
I have a question.
yes, ask.
Now, for example, I've already done my graph,
Yeah.
and now I want to probably transfer it to, let me say, PowerPoint or Power BI. How do I do it from Python?
Oh, from
Because maybe I
Python.
want to do a presentation somewhere, maybe, and I can't do it on the Python. How do I transfer now the graph to somewhere where I can present it?
Where you can maybe represent that.
Yes.
You're going to see how we do the save. We have a function to do that.
Oh,
To save maybe a file. You're going to see that.
and then another thing, how do I edit? For example, because this one seems to be a bit simple.
Yeah.
So, for example, if I want to do a bar graph
Yes,
or
I
a
think
line graph, how
again,
is it about?
again, you are
I'm
rushing now.
a bit ahead. Sorry.
You're a
Sorry.
bit ahead because
Mm.
I think there is something that I said about even this graph.
Mm-hmm.
But this is just like a sketch. You don't know what is happening with this graph. You don't have a
Okay.
title, you don't
Yeah,
have
I
a
don't.
text
Yeah,
label, you don't have
exactly.
we are going
Mm.
to see how we do that. It's just that we started with just a simple drawing. And then
Okay.
by the end of this MatPlotLib library, you will have learned everything.
Sawa.
Yeah.
Thank you.
So let us just check how we use markers. And I have an example here to use a marker. Mario, I think you're a bit ahead.
Sorry.
But eventually we learn it.
Sawa.
So let's have a marker. In this case, I just have some y values, and in this case, I just want to each and every point I want to use a marker. How do we do that? So I'm just going to pass my y point in the plot, and then specify the marker that I want to use. In this case, I just want to use a 0 marker. So if I want to maybe run these, you notice that my points, all my points are now represented as a dot. You can change this one to maybe something like asterisk. And if we run these, you again notice that all our points are represented as stars. That is in the case where you want to draw a graph, but you want maybe to specify each point using a marker. That is how we do it. You just have to pass your points in the plot method, and then you just use the attribute marker, and then you specify the marker that you want to use. I think that is basically that with markers. So let's move very fast to the other thing. There are so many things that we might not cover everything here, but there is so many things you can do to do some modification to the graphs that you are drawing in here. That is all about markers. Let's see how MatPlotLib line. I think we saw how we can have a line, and we are seeing that there is the line style, right? You might want maybe to use a dotted line. That one is covered under the line style, like the line style attribute that comes up with this plot. So let's say that you want to just draw, by default we draw a complete line, and you saw that, but you can specify the line style. Like in this case, we can just have a dotted line. If I told you guys to draw a dotted line, how would you go about it? You just have to specify the line style. Like let's just see this. If you wanted to draw a dotted line, let's see this. We just have the points and y points, and the line style here. You see that I have indicated it's dotted. So if I just again run that, you can see that I'm having a dotted line instead of instead of a complete line. So there is so many attributes that you can use while plotting, but I'll just cover the most relevant ones. That is all about line style. We're just going to pass through these attributes. Then you guys are going to practice later. What else? Let's take another thing here. What is this? I think that is all about the line style. You can add a line style. The other thing that you can add into your graph is now the labels. That is labeling the x-axis and having your graph titled so that at least you can mean something to people, right? So how do we do the labeling and the title? So again, we have functions to do that. We have a function to do the x labeling and the y labeling. Also we have again we have a function that is called title to do the title. So I think we can just have one example that we will have a title and our axis labeled. And I want us to use this example. So I can just copy this snippet of code and then we go through it together so that you can understand what is going on here. So the first thing is always to import your num. You can always start with maybe with Numpy as NP, or maybe start with MatPlotLib .pyplot, provided that you import them. So in this case, I just have some values here, and in the x-axis, I'm just going to have an average pass, and the y-axis will have the calorie, or the calories burned. That is the graph that I want us to draw, and I want it to have a title of sports watch data. So I'm just going to define my x and y values, and then I just put some values, random values. Also in the case of y, and then you notice that I think I have already said that when you want to plot, you just pass your values, that is x and y. Then plt.title, plt.xlabel, and then plt.ylabel. Then you just pass your title x label and y label. You just pass some string, or in this case you just have to pass a string that you want to be your title. In this case also your x label, and then you notice that I'm passing strings, right? In case you put just sport watch data outside or without maybe the opening and closing, you're going to get an error. You notice that for x and also y label, and then you're going to show. So if we run these, you notice that now our graph it makes sense, because we have a title here, sport watch data, and we have our x and y X and Y axis labeled. Like you can tell this one represent our calorie burnage and the average pass. So I think that this now make sense. Our graph is starting to make some sense. Yeah, I think that is it. With our graph now, it has a title, it has some labels. So that is how we do it. You can practice with different graphs, but basically that is how we do it. So after labeling our graph, what else do we need to know? I think we have seen that. We have seen how to do the title. So again, when it comes to title, you might want your title to be at the center. Again, maybe you want it maybe to be at a left or maybe right. So we have attributes for that, and you can always indicate that using the lock attribute, and then you indicate the position that you want your title to be. So like in this case, we just want, I think you can just use the example that we had here. So let's say that you want our title to be at the start. So in this case, it will be at the left. So we just have to indicate that the location you want it to be at left. So if I just run this, you notice that my title is at left. You can change this one to right. If we run this, you again notice that your title shifts to right, but in the rare cases that you're going to have your title at left. So I think that is that about title and the position in the title. So what I would urge you to go through the documentary for MatPlotLib so that at least you can learn even how to bold. You can write your title in bold. There is again attributes to do that. Yeah, so let's just shift to something else. So where do we go next? Let's see something else here. I think you have finished up with the location of the title. So next thing, I think we can just check the adding of grid lines. And so grid lines is, I think you know the mathematics book. It is always as it's squared, right? So the same case, you can add grid to your plot, and it's quite easy to do that. Let's just have an example here. We're going to run. You just have to, there is a function again to do that. You just have to invoke the plt.grid function, and you're going to have your graph having grid lines. So let's have this example again. You notice we're using the spot data, watch data. So if we have to run that, you notice that now our graph is has some grids. We do that by adding the plt.grid method. I think that one is quite simple. I think these are just simple things, but they means a lot when you want to make some visuals using Python. What else should we check? Yeah, I think now this one is an interesting part of this one is going to mark an interesting part of our lesson here. Now, what happens when you want to display multiple plots? We have a function that is called subplot function that will enable us to have two plots. So I think I can explain that using an example. Let me just explain that using an example here. And let's have that here. So in this case, we have plot 1 and we have plot 2. But you notice now we are adding something new here. The subplot method. So you're just going to define your x and y axis. You're also going to use the plt.plot x, y. But before that, you must add the subplot function. And also you indicate the point at which you want that plot to be located in the graph. So again applies for plot 2. So let us just go through something here up so that you can understand the meaning of the 1, 2 that you have just seen there. I think I have a good explanation here. So we are saying that the subplot function takes 3 arguments, and these are the arguments that I'm talking about. That is either 1, 2, 2, either 1, 2, 1. So let's see what are the arguments. We are saying that it takes 3 arguments that describes the layout of the figure. So the layout is organized in row and columns, which are represented by the first and the second argument. So the first and the second argument represent the row and the column, or maybe the point at which that plot will appear. And the third argument represent the index of the current plot. So like in this case where we have the plt.subplot 1, 2, 1. So the figure has 1 row and 2 columns, and this plot is at the first plot. So the second plot, the figure has 1 row, 2 columns, and this plot is the second plot. So let us just run these. I think when we run these, it's just going to make sense to us. Let us just run this code. And now we have 2 plots in the same graph. So we are saying that 1, 2 will represent the row and the column where we have our graph. So in this case, we have our graph at you can say at 0.12, whereby it is in the first row. It is in the first row, and we have our graph at we have the second graph at, and you notice that we are indicating even the position, the index position of these, which is at this point it is 1. The other subplot, again, it is in the same line, but in this case now at index 2. That is why you can see that they are in line. What if we indicated this one is maybe something to do with 2? Let's just change that one to 2. I think I wrote 2 the wrong position. Should be 2. So in this case now we are telling that our plot 2 should be at what position? I think this one should be 1. If we were to run this, that is 2, 2. Now this one should now be let's have these be something 3. Oops, why did we have that? We cannot move from index 1 to 3, so it must have to be 2. But let's say we want this one to be at 1, 1, 1, 1, 2, which is that position from what we have here. Let's see these again. Where's this? Where is this? I just right here. So let's see this, whereby we are saying that that argument represents the index of the current plot. So meaning that in this case where we have the plot at 1, 2, and then 1, it should be at index 1, and the second one should be at index 2. So the first two arguments here, that is 1, it is 1 row and 2 columns. So what if let's say let me just have a different graph here, so that I think this one will now make sense to us. Let us just have a different example here. That now we are going to change the positioning. Now we start with the position. We start with we have 2 columns. We have 2 rows and 1 column. I think this one will now make sense to us, whereby we are going to have both the plots in the same column. Let's use here. If we were to run these, you notice that now these they are no longer in the same row, but now they're in the same column. They are vertically arranged, unlike the first one where they were horizontally arranged. What do we change? We are saying that the first plot, it should be uh, at row 2 and column 1. And again, we are saying that the second plot again should be at row 2, the same row, and column 1, just to mean that now they are going to be vertically arranged, but with 1 2 1 2 they are going to be horizontally arranged. And the indexes, just this means that the first plot will take the first position, followed by followed by followed by the second position. What if we wanted maybe to have another plot? Now the third plot. Let's have that third plot here. You're going to use the same values here, but now this one you can indicate to be at position 3. So let us just have to run this and see. Oops. Where are we getting the error? Let's see, this num must be an integer. Again, this one it should be position. Let's see this. I think something is wrong with the indexing. Let me see what I've not added. So we have index 1. Let's check something here. Because you might be having maybe 3 plots, and you want them to appear on the same graph. How do you go about that? Let's see something here. I think we must change something. Let's go through that very fast. So the third plot, where do we want that plot? I think we want it at position maybe at row 3, right? And you have it at row 3. Let me see that. Let's see through this. Then at column 1. Let me just see through this. I think there is an error here that is saying that MatPlotLib deprecating warning how to remove of overlapping access is a deprecated since. Oops. I think something is overlapping. Have one. Again, something is overlapping. I think I'll just check this how you can add the third and the fourth the fourth plots. But in the meantime, you can just work with but I'll check how you can add this. I can see there is something changing here. We're told that MatPlotLib deprecating warning. Yes, I think there is something that I've changed. Auto remove of overlapping access is deprecated. Okay, I'll check through the documentary. I'll let you know how you can add the third and the fourth plot. But that is how you can have two plots on the same the same plot. So in a question, again you can add the titles. Where is this appearing here? You can also add the titles. The same case we did with the simple graph. You can add the titles. You can add the labeling of the axis. I think that one is we have an example that has that. I think you can just check below that, whereby you have the two graphs now labeled, having different titles. Where is this? Let's see, where is it? It's just somewhere here. Where is that? Okay, there is something different here. So you can add a title to each plot with the title function. It's just quite easy how you do that. Again, you just have to add the plt dot title for the plot one, and you do the same for the plot two. So I think that is something simple. But again, we have something that we are calling the super title. And the super title means that you can add the title to the entire figure. That is why we have in the sub title here. It is the super title function. You can add a title to the entire figure. So you can have like this one. I just have to run this code so that you can see what super title means. You can just copy this and run it here. So you notice that now we have already added the subtitle, and you notice that now our two graphs have the sales graph and the income graph. You notice that you're just using just dummy data here. So we have the sales and we have the super title. You can modify this further by you just learn how to add bold to title. Maybe you can use italic if you want. There is so many attributes when it comes to the titles, so you can just go and check them. But that is how you add a super title to your graphs. So the other thing I think it's the thing that I think we should check is how to do what is protein. Okay, I think you can just also check how we plot some other graphs apart from line graphs. Maybe you would want to draw a pie chart. You would like to draw a histogram. Again, it's just quite easy because again Python will provide you with what you need is data, and the rest Python will do for you because it has methods for that. Like for pi, we have the pi method. Let's see this. I think you are done with two plots, the super title. Yeah, and again you have another graph here, another plot which is called scatter. Let's say you want to draw a scatter graph. I think most of all of us, if not most of us, knows about the scatter plot. So again, you can do that. We have the function for that. Let's say the scatter function plots one dot for each observation. It needs two arrays of the same length. And why do you think we need we have two arrays of same length? It must be of same length, by the way, because each and every point must have x, y value. That is why we even have x and y. So that now we can have each point is always presented as an x and y. So that is why we have two arrays with same values, same length, I mean. And I think you can just be run through these and just see just a simple scatter. But it's just the same. You just have like to know the methods as we have in Python and how they are used. You can just have these. We run through these. Is that you notice that you have now a scatter plot. So it's upon you to put the title, the labeling of the axis, like we have learned. So, but this is simply how you can do a scatter. So the first thing, you define two arrays with the same number of elements. The other thing, use the scatter, and then you pass the x and y. And after that, you can decorate. You can add. We call them decorations. You can add the x label, the title, and also the y. The y label and the x label. I think after doing that, you can shift to other types of graphs, such as pie chart. There is somewhere we have pie chart. Creating a bar graph, bars. I think someone asked, is it Mariwa? Mariwa, you asked about bar graphs. I think I said we have a function to do that. We have a function that is called bar function to draw bar graphs. You can have horizontal bars, you can have vertical bars. Yeah, it's just quite easy. So let's have just one. I just want to rush through these. Very fast. Let me just copy that. And if you have any question, you can just ask as we go through. The reason why I don't pay much attention to this is because these are things that you can maybe go through at your own time, because they are just quite simple. So let's see these. We have we want to draw a bar graph here. So again, we must have the x and the y. You notice that in this case we just have labels for the x-axis, and we have some values for y. And again, we just have to invoke the bar method, that is plt.bar, and we run through it. Then we have a bar graph here. Mariwa, Mariwa, are we together, Mariwa? I think this is the bar graph you were asking.
Yes, we are.
Yes. So the other part of I think the other thing that we should maybe use
Okay.
is pie chart. Yeah?
So now, James.
Yes.
So labeling, you just go the same process.
Yes. That is why it's quite repetitive. I don't know how to do. I don't know how to repeat that in all cases.
Oh,
Yeah. But it's the same case. You
wow.
just use the plt dot title, plt dot x label, y label. You know, it's tedious.
Okay.
Yes, I want just to go through the main thing. So the other part is I think you can just go through. This is the pie chart. You can just go through the pie chart. I think pie chart has something to learn there. Yeah, pie chart. We have an example of a pie chart here. And in pie chart we have something we call explode. So let us just have a simple chart, a simple pie chart. Again, we have it's very simple to implement this. I think Python is the simplest programming language when it comes to even visualization. Because again, in here, you know that a pie chart we must have some values, and we must have some labels, right? And to draw a pie chart, you're just going to pass two arguments. That is the values for your chart. They can be percentages, you know. In this case, we just have just random numbers. That is 35, 25, and we have what? We have 7, 15, and then we just pass in our labels. And our labels we want the first index here we'll take the label apple, the second one banana, the third one cherries, and I don't know which kind of fruit is dates, but just you can just put some orange. Then we just have to plt.py, we pass in the data in the labels. You notice that the labels, I'm equating it to my labels, and then plt show. If I run these, you notice that I have my beautiful pie chart here that has cherries, bananas, apples. Alright. So there is something interesting with the pie charts, such that you can change these colors, so that at least maybe we can have colors, maybe having an orange color, you can have apples with the color, you can have bananas with color, cherries with the color. So you can you can add that. Those are some of the modifications that you can add in your pie chart. But in this case, I just want us to check something that is called explode. And explode, we are saying that maybe you want one of the wedge to stand out. The explode parameters allow you to do that. So let's see how we do an explode. And we are saying that the explode parameter, if specified, and not none, must be an array with one value for each wedge. And each value represents how far from the center each wedge is displayed. So let's say if you want maybe you want to have an explode for apple, we are going to set some value, and then the rest will be from the center they will be zeros. So let's see that, and also you are going to include that in your pie method. So let's see that. Again, it's just the same thing that we are doing, only that we are adding now explode here. Let's have it here. Control all. Oops. Let me just have this commented out. So you notice that you are doing an import matplotlib.pyplot. The same case we did with the other pie, Numpy. Then we have our array of values. And then we have our labels again. But now in this case, we want to introduce explode. And we said that this value, to introduce explode in your pie chart, you must have again a list of some values here that will indicate how far from the center should these values be. So in this case, we just want apple to explode by 0.2, and then the rest will just remain intact. So when it comes now to pi, we are going to pass three things. That is our value y, our labels, and then the explode is equals to my explode, and then we show. Let's see that very fast. You see, this is what we are calling explode. Sawa. So you notice that this is the distance from now here is what we are calling 0.2 from the center. Maybe you can change that one. Maybe let's say you want to have explode at the second index. Maybe you can put 0.3, and at index 2 we have bananas. So if we run these, you notice that banana will explode. That is it. So it's upon you to learn the many methods you can do to modify your chart to suit your case that maybe you are doing analysis for. I think I haven't checked that. I think we can just leave at that point. Yes, I think we can leave at that point. And then tomorrow we are going to learn maybe something to do with, let's see what we are going to cover tomorrow. Yeah, but we are going to continue with these. We are going to see what is aligned, how it is done. You're also going to see some what is the shadow, how to do it, and some other concepts. So, any question up to today's work?
Will you kindly share the notes?
Sorry?
Class, you share the notes.